Good morning, beloved chemists. I hope you're having a wonderful day. Today, we are returning to our old friend. Dun 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 dun! Return of Mole Island. Woo! Plot twist, we're going back to Mole Island, which is good because stoichiometry will show up on your end of your exam, so you may as well learn how to do it with gases. Now, as a concession to our online learning, I am only going to teach you one way to do gas stoichiometry when there really are three ways. So today I'm going to teach you one way to do gas stoichiometry. Tomorrow, you'll have a worksheet that only has you doing it that way, and your tests and quizzes and your lab will all have it the same way. The day after that's due, there will be an optional extra credit video to watch to see the other two ways, and then optional extra credit homework after that to show me that you learned the other ways. If you're thinking you're going to go on and take more chemistry next year, you might try those other videos. Or if you're looking to boost your grade, you might try those other videos as well. But they are not required. We will only be doing gas stoichiometry this way. Okay, let's read the question. You are asked to design an airbag for a car. You know that the airbag should be filled with a pressure higher than atmospheric pressure, say 829 millimeters of mercury, at a temperature of 22 degrees Celsius. The bag has the volume of 45.5 liters. What quantity of sodium azide, NaN3, should be used to generate the required quantity of gas? The gas producing reaction is NaN3 goes to sodium and nitrogen. So for this reaction, this is a reaction that blows up your airbag in the car. It quickly fills a large bag with air and makes it possible to save your life. These compounds are extremely reactive. Only just touching them sometimes can cause them to explode. So azides are used very carefully because of that. So let's think about what's going on here. They've given me a bunch of information about this gas I want to use for the airbag. A bunch of information like 45 liters and some pressure and some temperature. And so to me that all seems like gas information. I've got a bunch of gas information. And if I were doing this with my picture, that would put me on this hot air balloon. And hot air balloon where I have pressure, volume, and temperature. But I learned from PV equals nRT that I can use pressure, volume, and temperature to get to Mole Island. So the first step in this problem is going to be number 1, PV equals nRT, where you're going to take that gas information and turn it into moles. And then if you remember our process on Mole Island, our next stop was to go to the Mole Mart. Our next stop is to go to the Mole Mart. And at the Mole Mart, we do something called stoichiometry. And we exchange one chemical for the other chemical. So we're going to exchange from our gas to, well, what are we looking for? We're looking for sodium azide, so we're going to change to sodium azide. And what are we looking for about that sodium azide? We're looking for its mass. We're looking for the mass of sodium azide. So the last step will be to go back out to the mass ship. And this is where you use molar mass to get from moles to grams. If you can hear that in the background, that is my dog complaining that I'm talking to myself when he wants to take a nap, so I'm sorry. Okay, so if we're going to do this process, we're going to start with PV equals nRT. So what's my pressure here? My pressure, 829 millimeters of mercury. Okay, my volume, 45.5 liters. N is what we don't know. R is always 0.08206 liter atmospheres over moles Kelvin, and my temperature is 22 degrees Celsius. Okay, but those are not the correct units. I've learned I've learned from PV equals nRT before that I have to have these in atmospheres. So I'm going to multiply by 1 atm over 760 millimeters of mercury there and get that one. And this one I'm going to add 273.15 Kelvin to get that one. That'll be 295.15 Kelvin. The top one, forgot to bring my calculator to the party. Because you know, there ain't no party like a calculator party, because calculator party can Okay, I miss you guys. Nobody rolls their eyes when I make stupid jokes. The dog groans, though, so I guess that's kind of the same. But the dog groans regardless of what I say, whether it's a joke or a regular word. Okay, so 1.09 ATM. And then we're going to plug this into PV equals nRT, our new friend. $290. Okay. This one is 49.595 on this side. You should do this in your calculator too. Divide both sides by 24.22. And you get moles are equal to 2.05 moles. Now, if we're going to do stoichiometry, we got to know moles of what. We've kind of gotten away from that this chapter because we were just finding the moles, but we need to know moles of what. So this moles of the gas. Let's look at this picture here. Moles of the gas. Which one of these is the gas? Well, there's an indication in here of which one is the gas, and it's this little g here. So we know that this is 2.05 moles of nitrogen. So now I have to do stoichiometry. 2.05 moles of nitrogen times, I have to switch it from moles of nitrogen to moles of NaN3, because that's what I'm looking for. I'm looking for the sodium azide. And if you remember, I know it's been a while since February, to get the ratio that goes in here, we use the coefficients from the balanced chemical equation. So with NaN3 goes the 2 that's in front of NaN3, and with N2 goes the 3 that's in front of N2. So we multiply that by 2 over 3. We get 1.37 moles of NaN3. Last step, use the molar mass. So we've got 1.37 moles NaN3 times 1 mole NaN3. And up here we need to put grams of NaN3. And just a refresher, to get the grams of NaN3, you get 22.99, which is the molar mass of sodium, plus 3 times 14.01, the molar mass of nitrogen. So that's a blast from the past. And you get that the molar mass of that is 65.02, so that's what goes here. Multiply that by 1.37, and we get our final answer, which it looks like we have 3 sig figs, so 89.1 grams of sodium azide are needed to blow up this airbag. Okay, I know that was a lot to take in, and there's only one example in the notes like this, so with the homework, there will be an optional video to watch me do another problem if you need another help. Okay, take care.